This week, we'll continue talking about Voila by making a little bit more advanced calculator and actually creating a simple web app from it. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, we're going to take the basics that we set up last week on using Voila and a widget refresher, and we're going to make a simple calculator. In this case, it's going to be for density altitude. Then we'll use Voila to make it a web app. And then next week, we'll work on tweaking the layout and doing some fancier things. But this week will be a relatively simple calculation. To calculate density altitude, there are lots of ways you can do it. We're going to use some approximations that I've outlined here. So first, we're going to calculate the pressure altitude, which is the standard pressure minus the pressure setting, or referred to as the altimeter, times 1,000, plus the elevation of where you are. Then the density altitude is the pressure altitude plus 120 times the difference between the outside air temperature and the international standard atmosphere temperature. Now you can find the ISA temperature several ways. We're going to use an approximation that's outlined here, which is we're going to double the altitude in thousands of feet, subtract 15, and multiply by -1. Again, these are crude, but it's going to give us something to work with to demonstrate the concept of making these calculators and how quickly and intuitively you can do it. This is great because having somebody look at the equations and say whether density altitude is going to rise or fall based on altimeter or temperature settings is a little bit not so straightforward. But if you've got a slider that you can drag around and see what the effects are, it becomes more intuitive. So let's get started. I've deleted everything that we did last week except the import IPy widgets as widgets. Now we're going to create sliders and output text boxes for everything we need. So we need a pressure setting, an elevation, and a temperature input. Then we're going to have a pressure altitude, standard temperature, and density altitude output. So our pressure setting is going to be widgets. I'm going to use the float slider. I'm going to set the minimum to be 28 and the maximum to be 31 with a step of 0.01. The starting value to be the standard altimeter setting of 29.92. And the description is going to be pressure setting. And because these formulas are geared in these units, we're going to be doing it in inches of mercury. It would be a good challenge to go ahead and take what we do here and adapt it to use all SI units instead of the mix that these formulas use. All right, elevation. Elevation, we don't really care about getting sub-foot elevation. So I'm going to use not an int float, but an int slider. For the minimum, I'm going to let that be -1,000, and the maximum will go to 10,000. A step of 10 feet ought to be plenty of resolution, really. And we'll start out at sea level. The description is going to be elevation, and that's in feet. Temperature. Again, an integer slider is probably fine. The minimum of -40, the maximum of 60. A step of 1 should be plenty. We'll start out at the standard temperature of 15. And the description is going to be temperature, and that's in degrees Celsius. And again, you notice all the typos here. That's really how I type, and that's why I love tab completion, because it keeps me from making those kind of mistakes. All right, now for our outputs. So the pressure altitude. This is going to be widgets.float text. And we want it to be disabled because we don't want people to enter things into it. We just want to use it as a display. The description is going to be pressure, altitude, and that's in feet. Now I'm going to copy the first part of this and paste it for my next two. We're going to have the standard temperature that we calculate, and finally, the density altitude. We'll add our description. This is going to say standard temperature in degrees Celsius. And the description for this will simply be density altitude in feet. Okay, so finally we have all of our widgets created. We're going to create a calculation function just like we did last week. I'm going to calculate pressure altitude, the standard altimeter, 29.92 inches, minus the pressure setting, the value attribute, times 1,000, plus elevation. Now time for the standard temperature. The standard temperature is going to be the elevation value divided by 1,000 times 2 minus 15, all multiplied by -1. Again, remember this is a rough approximation, but it's good enough for calculating density altitude, which is the last thing that we need to calculate. It is the pressure altitude plus 120 times temperature, the value attribute, minus the calculated standard temperature. Now we just have to set our displays. So the pressure altitude, I want to set the value attribute of it to be the string representation of the pressure altitude that we've calculated. The value attribute of standard temperature is going to be, you guessed it, the standard temperature that we calculate. And finally, the density altitude will set to be our calculated value of density altitude. Now we just have to hook these things up. The pressure setting, we're going to use the observe to say run the calculate function when there's a value change. Now we're going to do the same thing for each slider because we want to recalculate if the user changes any parameter, not just one. So elevation.observe, and finally temperature.observe. Things are hooked up. We need to display them. We're going to use a simple vertical box again. We will make this a little bit more advanced next week. So we're going to use the pressure setting first, the elevation, the temperature setting. Then we'll put our displays of pressure altitude, the standard temperature, and the density altitude. Now if we run that cell, Here we've got zeros because our calculation function has not run yet. But as soon as we move any slider, we can see the effect. So for example, changing the temperature only changes the density altitude. It, of course, doesn't change the pressure altitude or the calculated standard atmosphere. Changing the elevation changes all three. Changing the pressure set point changes the pressure altitude and the density altitude, but not the standard temperature. So what does increasing pressure or altimeter setting do to density altitude? Well, yeah, it lowers it. So, playing with these sliders is a great way to understand what's happening. You will notice that there are some truncations to our descriptions, and maybe we want to change the layout of this a little bit, and that's what we'll get to next week. But as a little bit of a tease to that, I want to show you how to use Voila to view this as a web app. So you can create a new tab and just change Lab to Voila. Now when you're here, you'll see a bunch of notebooks that you can select. I'm going to select our Part 2 demo. And now here is your notebook, but running without any of the Jupyter Lab or code exposed, just as you would see it on a simple web app. So like I said, next week we'll dress this up a little bit and make it look more like a professional web app. And we'll also use the Voila command line tool to run it, not using the Jupyter Lab server. I hope that you found this useful, and I'll see you on next week's MetPy Monday.